Hello everyone, we're going to play a review game of Two Truths and One Lie about the nature of science or the scientific method. If you forget how to play this game, I'm going to show you 3 statements, 2 of which are true, 1 of which is false. What you have to do is you have to figure out which of the 3 statements is the incorrect or false one. All right, here's our first set of statements. Number 1, science is based on evidence that can be observed and measured. Number 2, theories in science are guesses. And number 3, theories can change. So which of these 3 statements is incorrect or false? The first and third statements are correct while the second statement is false, and let's go over why. Number 1 is true because in science, this is what the main focus is taking observable and measurable data. Number 3 is also correct, and it might sound a little bit odd, but theories can and do change. This is part of the scientific method, and part of science is that theories become more accurate with more evidence. Can we disprove a theory and change a whole aspect of a theory? Yes, we just need the evidence for it to change. Number 2 is incorrect because theories in science aren't just guesses. Theories are well-tested explanations with massive amounts of evidence that support the claims and the explanations behind them. Here's our next set of statements. Number 1, the independent variable is the one the scientist changes. Number 2, a controlled experiment tests one variable at a time. And number 3, data from experiments should always support the hypothesis. Which one of these statements is incorrect? The first and second statement are correct, while the last one is incorrect. Let's go over why. The independent variable is the variable that the scientist changes, while the dependent variable is the variable that the scientist takes data from. So the dependent variable is obviously dependent on the one that the scientist changes. Number 2 is also correct because in a controlled experiment, we want to limit the number of variables that's acting on the data. So what we're going to do is we're going to only change one variable so we know how that one variable is affecting the data collected from the experiment. The third one is incorrect. Data from experiments should always support the hypothesis. So a lot of times in science, the data will actually disprove the hypothesis, or it just won't agree with the hypothesis. So one of the things we look at is how does the data, or how significant the data is against or for the hypothesis. So a lot of times, we'll disprove a hypothesis because the data just isn't significant enough. So the idea that data always has to fit within our hypothesis just isn't how science is done. And here's our last set of statements. Number 1, experiments that disprove a hypothesis are failures. Number 2, hypotheses are based on observations. Number 3, a hypothesis must be falsifiable. So which one of these statements is false? The first statement's false, while the number 2 and number 3 are true. Let's go over why. The first one is false because disproving a hypothesis still provides valuable scientific information. And one of the things I like to teach to my students is progress is progress. Even though an experiment might not go the way we think it should go, or it might just disprove the hypothesis that we have, it still progresses science forward. It still teaches us something. We still can learn from that experiment. So progress is progress, even when a hypothesis or an experiment fails. Number 2 and number 3 are true because hypotheses have to be based on really observations and past knowledge. A hypothesis also must be falsifiable because that's part of the scientific method is that it must be able to be disproven.